Hello, math fans. Just a quick comment. I can't help myself here because somebody out on the discussion board is asking about finding the x-intercept, which is a really good question. It's not really about their question. It just got me thinking about what do we even mean by the equation of a line. So if I say this is the equation of a line, in my class I talk a lot about it being the condition for what must be true for a point to be on that line. And I say that because I feel like it's very easy, and I did it too as a student, just to sort of memorize. I think they said that this is slope and this is intercept. I think they said the numbers are supposed to go here. I don't know what to do here because it doesn't look like what I'm used to. And so I think that's the overarching problem sometimes, is people don't realize what this is saying is that if I drew a picture of this line, it doesn't even have to be a picture, but let's draw a picture anyways. And in class I actually derived it, so that's not what this video is. The video is this. I want to describe all these points. That's the goal. The goal is not to write down 3 and 7 and x and just blindly follow it. I would say this tool is so prevalent that we need to be able to go a little bit under the hood of what it is. This tool is saying, you hand me any one of these points, whether it's a point here or it's a point here, and it works in here. That's really the point. Then we use it to find intersections or make predictions out the future or whatever. So when someone says they know how to find the y-intercept, but they don't know how to find the x-intercept, it's this misunderstanding. Both those things are in there. I don't think of them as different. It means that we're looking at it and just blindly remembering what this is and not understanding. So if you know how to find the x-intercept but don't know how to find the y-intercept, then you're blindly following the formula, which is a good note, not a criticism. So let's label this point. This is just one of many points on there. It happens to be the point where x is 0. What about this point over here? It's one of many points on there. It happens to be a point where that is. Those aren't special. Somewhere over here there's a point where the x is 4. Somewhere back here, there might be a point where the y is 2. If we know the x or the y, we know how to get the other one. Let's just plug it in. We're so programmed to have it on one side or the other, but it doesn't matter if it's one side or the other. You could write it this way, and it's still the equation of the line. In fact, if I do that, a bunch of students get lost. But the real thing is we're just going to plug in. So for example, if I plug in a 0 here, I can solve for x. So I subtract the 7, divide by 3, this is negative 7/3. If I plugged a 2 in for y, like this point, this would be a 2, I'd subtract 7, this would be negative 5/3. If I plugged in a 0 for x, yeah, that happens to be easier, I get 7. Plug in a 4 for x, I get 12, I get 19. All of those points we're getting. So if we're only knowing how to use the equation to find this one point, we're missing out on what it's actually saying. Okay, so same thing here. Here's an equation. Yes, it's a positive. It's very helpful to find the y-intercept because it's easy to see, but that's just one of the many things we could plug in. When you're finding the y-intercept, you should think, I'm plugging in x equals 0. It's not a blind memory thing. Okay, so I'm plugging in x equals 0. That gives me a negative 10. Let's also plug in y equals 0 and see what we get. It's just one addition and division, so x is 5. It needs to be kind of on the routine, and you could get any other value you wanted. When you plug in a 1 for x, you get a negative 8. When you plug in, what do I want? A 3 for y, I get, so you put a 3 here, 13/2. All right. So the point of all that is, it is very common in applications that you might get the equation of a line like this. Like something that says 3 times one thing plus 4 times another is 12. That's a perfectly good line. Everything's to the first power. It's just written in a different way. And you don't have to get y by itself. In fact, I would prefer to leave it how it is because I can see the intercepts right away. If x is 0, what happens? Well, if that's 0, I can just divide by 4 and I get 3. So when x is 0, y is 3. When y is 0, what do I get? Oh, x is 4. And so I actually would argue that this form is easier to use. So why do we do the slope form? What is the best form? I don't care. I don't care the form. I just know those are all lines. And that I can plug in anything I want for one of the values and get the other value, get 2 points. So I hope that gives a little bit broader understanding, is when I look at that, it's a condition for what it means to be on that line. If anybody's interested in me showing the derivation of that, which has to do with the ratio, I can also do that, but I did that in lecture. All right, hope that sort of clarifies.